Hello everyone. So today we want to do proof by mathematical induction. So we want to answer this question: prove by mathematical induction that for all positive integers n, 1 plus 3 plus 5 plus dot dot plus 2n minus 1 is equal to n squared. So when proving by mathematical induction, we are going to follow three steps. So the first step will be we verify if the statement is true for n is equal to 1. So meaning we're going to get 1 and put where there is n and prove that this statement is true. So 2n minus 1 is equal to n squared. So where there is n we put 1, so it will be 1 minus 1 is equal to 1 squared, because we have simply put 1 where there was n. So this will now be 2 minus 2, because 2 times 1 is 2. So it will be 2 minus 1 is equal to 1, which means 1 is equal to 1. So the first step holds because we have proven that the left-hand side is equal to the right-hand side. Then we come to step 2. Step 2, we assume that the statement holds for n is equal to k. So we assume that the statement holds for n is equal to k. So where there's n, we simply put k. So it will be 1 plus 3 plus 5 plus dot dot plus 2k minus 1, which is equal to k squared. So this is true because wherever there was n, we've simply changed to k. The only thing that we have changed is the sign, but this statement and this statement are the same. It's just the letter that is different, so we assume that that is true. Then we come to the step 3. If the statement is true for n is equal to k plus 1, then it holds for all n. So the thing is, this is where the main proof is. This is the bigger picture of proof by mathematical induction. If this one holds, then we are assured that for all n, it holds. If n holds for k plus 1, then it holds for all n. So notice this. For n is equal to k plus 1, we'll have this. 1 plus 3 plus 5 plus dot dot plus 2k minus 1 plus 2k plus 1 minus 1. Notice that before we reach k plus 1, we have to first pass through k. That is why we are getting for k, we got this up to here. We got this for k. So meaning it is this statement that we are going to add a k plus 1 to. So this statement up to here, the second statement up to here, plus now the one that is having k plus 1, which will be 2k plus 1 minus 1. Where there was n, we just put k plus 1. Even here we put where there was n, it was n squared, so it becomes k plus 1 squared. So now, notice that the second part is what we had for k. And we noted that this is equal to k squared. So we can simply replace, from here, we can simply replace the second part with k squared, because this statement is the same as this. So k squared comes in place of this. So we now have k squared. When you expand this, it will be 2 times k, 2k plus 2. So 2k plus 2, there is a minus 1 and minus 1. And notice that k plus 1 squared is the same as k plus 1 times k plus 1. So we now have k squared plus 2k plus 2 minus 1 is equal to k plus 1, k plus 1. So when we expand this, we will have k squared plus 2k, 2 minus 1 is 1. So k squared plus 2k plus 1 is equal to, this expanded will give us k squared plus 2k plus 1. So noticeably, we have that the left-hand side is equal to the right-hand side, which means the last axiom, the last step 3, holds for for n is equal to k plus 1. We have that the left-hand side will be equal to the right-hand side, and hence this holds for all n, and hence we've proven that this statement is true using mathematical induction. The whole idea is to prove that the left-hand side will be equal to the right-hand side for k plus 1. So since we have shown that for k plus 1, the left-hand side is equal to the right-hand side, then it is indeed true that the statement holds.